Internet Key Exchange, IKE, is a protocol used to establish security associations, SHAS, and negotiate cryptographic keys for secure communication in IPsec-based VPNs, virtual private networks. It's a critical component of setting up a secure channel between two parties over an untrusted network, like the Internet. IKE ensures that both sides of the communication have a shared understanding of encryption, authentication, and other security parameters before data transmission begins. Here's how IKE works. Security Association, SA. A security association is an agreement between two parties on the methods and algorithms they'll use for securing their communication. It includes details such as encryption algorithms, authentication methods, key lifetimes, and other security parameters. IKE Phase 1, ISAKMP. The initial phase of IKE is known as Phase 1 or the ISAKMP, Internet Security Association and Key Management Protocol, phase. During this phase, the two parties, often referred to as peers, establish a secure channel to negotiate the terms of their communication. They agree on the authentication methods, encryption algorithms, and other parameters. IKE Phase 1 typically involves 1. Authenticating the parties involved. 2. Negotiating encryption and integrity algorithms. 3. Exchanging Diffie-Hellman public values to establish a shared secret, used for deriving encryption keys. 4. Creating a secure channel through which Phase 2 negotiations occur. IKE Phase 2, Child SA. Once Phase 1 has been established, the peers move on to Phase 2, also known as creating child SHAS. This phase focuses on negotiating the security parameters for actual data transmission. It includes details like the specific IP addresses to protect, the type of encryption to use, and the key lifetimes. IKE Phase 2 involves 1. Negotiating IPsec policy details, like encryption and authentication algorithms. 2. Creating the child SA that defines how data will be protected between specific endpoints. Keys and SHAS establishment. After both phases are complete, the peers have established a set of security parameters and shared cryptographic keys for their communication. These parameters are used to encrypt, authenticate, and protect data as it's transmitted between the two parties. Regular rekeying. Cryptographic keys have a limited lifetime for security reasons. To maintain a secure connection, IKE and IPsec systems often perform key rekeying. This involves renegotiating keys and security parameters periodically or based on certain triggers, like reaching a specified amount of data transferred a predefined time period. IKE ensures that secure communication can occur even when parties are communicating over an insecure network, like the Internet. It's essential for the proper functioning of IPsec-based VPNs, providing the foundation for establishing secure tunnels between devices or networks. Note that there are two main versions of IKE, IKE v1 and IKE v2. IKE v2 improves upon some of the limitations of IKE v1, such as better handling of network changes and more streamlined negotiation processes, making it a more modern and preferred choice in many cases. IKE operates as a separate protocol within the IPsec suite and plays a vital role in simplifying and automating the setup of security associations. Here's how IKE works. Security Association, SA, establishment. A security association is a set of security parameters that are agreed upon between two devices or networks to secure their communication. IKE facilitates the creation of these SHAS. Key negotiation. IKE uses a process called key negotiation to establish shared cryptographic keys between the two parties. These keys are then used for encrypting and authenticating the data exchanged over the secure channel. Phase 1 and Phase 2. IKE negotiation typically occurs in two phases. 1. Phase 1. During this phase, the parties negotiate a secure channel and exchange the necessary parameters, such as encryption algorithms, authentication methods, and the Diffie-Hellman key exchange parameters. 1. The goal is to establish a secure, ISAK-SA, Internet Security Association and Key Management Protocol Security Association, which will be used for further negotiation. 2. Phase 2. In this phase, the established ISAKMP SA is used to negotiate IPsec SHAS. 2. These IPsec SHAS define the encryption, authentication, and other security parameters for the actual data transmission. Diffie-Hellman key exchange. IKE often employs the Diffie-Hellman key exchange algorithm to securely exchange cryptographic keys without transmitting them directly over the network. This ensures that even if an attacker intercepts the traffic, they cannot easily determine the keys being exchanged. Authentication. IKE also handles authentication between the communicating parties to ensure that both sides are legitimate and authorized to establish a secure connection. IKE comes in two main versions: IKE v1 and IKE v2. IKE v1, Internet Key Exchange version 1. This is the earlier version of IKE and is widely supported. It has a more complex setup process and often requires additional ports to be opened in firewalls, which can be a potential security concern. IKE v2, Internet Key Exchange version 2. IKE v2 was designed to improve upon the shortcomings of IKE v1. It is more efficient and offers improved security. It can also work more effectively in scenarios where devices frequently change network connections, such as when devices switch between Wi-Fi and cellular networks. IKE is a critical component for establishing secure communication, especially in scenarios where IPsec is used for creating VPN connections or securing network traffic. It ensures that cryptographic keys are exchanged securely, reducing the risk of vulnerabilities due to weak keys or manual key management.